Hey everyone, Geophysicist Stefan Burns here. Interstellar object 3I Atlas is now flying through the main asteroid belt. And this is something that not many people have really commented on, or at least the scientific community hasn't really done a deep dive into what this means, because there is a non-zero probability that 3I Atlas hits something in the main asteroid belt, which causes it to redirect in its orbit with its velocity and with its trajectory. Because right now it's coming in with a hyperbolic orbit at around 60 kilometers per second from, it seems, an interstellar source. This could be from a different star system. It came in from the constellation of Sagittarius, which is general where the center of the Milky Way is. And there is some interesting research out there by Avi Loeb that shows that a red dwarf star is dense enough to cause a planet to fracture and also eject objects at velocities right around what we're observing with 3I Atlas. So perhaps that is its primordial origin. It was originally some sort of protoplanet around a red dwarf that fractured, and this is a fragment of that. The nucleus size for 3I Atlas is estimated to be around 1 kilometer in diameter, all the way up to perhaps 50 kilometers in diameter. It really depends on the dust envelope and that albedo. We have no direct observations of the nucleus of 3I Atlas at this moment in time, but we know that the carbon dioxide rich coma, this envelope of dust and gas and a bit of plasma surrounding 3I Atlas, is approximately 700,000 kilometers across, which is half the diameter of the sun. So 3I Atlas is very bizarre. It is forming a tail now, as we see here with this video taken by Gemini. This was August 27th, 2025. So as I'm recording this, some time has elapsed now. And right now, in fact, is the best time to take imagery of 3I Atlas, because it'll be performing a superior conjunction with the sun as viewed from Earth around October 21st, meaning that it's Earth, sun, and then 3I Atlas on the other side. Once it gets within about 15 degrees of the sun from our geocentric perspective, it's going to be really difficult to make out 3I Atlas. But this journey through the asteroid belt is significant. Now, it's very unlikely that 3I Atlas will interact with anything. It's about a 1 in a billion chance for when we send a space probe through the main asteroid belt that it's going to interact with anything. And those odds are probably a little bit higher because 3I Atlas is a lot bigger, has its own gravity, and there's electromagnetic forces as well, but still it's a very low probability. But no one's done an official calculation on all the objects that we know of in the main asteroid belt and 3I Atlas and whether there's going to be any close calls, because there is a tremendous amount of overlap between these objects, their orbits, and their inclinations, and the trajectory of 3I Atlas through the inner solar system. So we have a lot of interesting things happening right now with 3I Atlas because of its very unusual characteristics. This complex dusty plasma which surrounds it is interacting with the overall electromagnetic system of the heliosphere. And in fact, there are a lot of electromagnetic dynamics in play with the asteroid belt. And so perhaps we'll see some interesting interactions between 3I Atlas and the main asteroid belt during this next month of its flyby. And before we go further into the asteroid belt and the movement of 3I Atlas through that, let's look at this still image of 3I Atlas taken by Gemini South. This is from the same data set of observations. And so we see here that it has a very nice large coma, and it is starting to elongate into a tail. So the sunward direction is this way. This is anti-sunward. Originally, when we first observed it, when it was further out, there was a little bit more gas and dust pushing out in the sunward direction, likely due to preferential sublimation on that side. But now we're seeing it get kind of pushed out into a tail, though it's not as obvious as a lot of comets. A lot of comets have these really long tails with these very intricate structures. They form these ion tails, dust tails. Specific elements can form tails like iron. So you can have multiple tails with one comet. 3i Atlas is still not that close to the sun, so it is forming a tail, but it is not anything really spectacular at this moment in time. So it's going to be really interesting to see specifically how it evolves over the next few months as it gets closer and closer to the sun. It's perihelion. It's the closest approach to the sun will be on roughly October 29th. And we have that superior conjunction with 3i Atlas. So again, Earth, Sun, 3i Atlas, where we're not going to see it. That will be on around October 21st. Its closest approach to Mars is October 3rd. And so a lot of people are speculating that this is some sort of alien technology or craft or something like that. In that case, if it is targeting Mars, it would want to deploy around October 3rd. And we're just entertaining all possibilities here. Now, the other thing that few people have talked about is that the asteroid belt is composed of billions of objects, going from sand size, like a sand grain, all the way up to Ceres, which is the dwarf planet in the asteroid belt that makes about 1/3 of the mass, has a diameter about 900 kilometers. So there's a tremendous range and variability within the asteroid belt. And it's not just objects that were formed during the initial protoplanetary or protostellar disk phase in place. A lot of the objects in the main asteroid belt actually came in from outside the orbit of Neptune. They're trans-Newtonian objects. And so the main asteroid belt is this repository of a whole bunch of different objects from across the solar system. And therefore, if we're talking about 3i Atlas from some sort of alien or technological perspective, then you should consider the possibility that it could slip right into the asteroid belt, and that's where it decides to stay. Because Ceres at 900 kilometers in diameter is quite a bit bigger than 3i Atlas. In fact, there are thousands of objects in the main asteroid belt that have diameters greater than 40 kilometers. And the upper estimate for the diameter of 3i Atlas, based on some recent data, is 50 kilometers. Much, much, much larger than most objects, comets, asteroids, etc. So there is this possibility it could slip in, but that would necessarily almost mean that it has some sort of advanced technology inherent with it, because unless it was to do a collision that then redirects it into a stable orbit around the sun in the asteroid belt, it's going to continue to fly by. But let us check out its orbit, because it actually does pass right through the asteroid belt, whereas a lot of comets do not because of their high orbital inclination. 3i Atlas is 175 degrees inclined in retrograde motion, meaning it's only 5 degrees off from the ecliptic plane. It's passing right through the meat and the body of the asteroid belt. Here we have the web application, the Sky Live, which allows us to see the solar system and various objects that we put into the solar system. And so I have 3i Atlas here. Its orbit is in green because that is the object that's selected. We see it here, and this is actually set for the 8th of October now, but we can go back to today to see where 3i Atlas is. And we'll see that's already well within the asteroid belt. So we zoom out. I only have the first 20 asteroids detected in this visualization, because that's actually kind of the limit that I can put in. So asteroids 1 through 20, which are the most well-known ones. For example, asteroid 1 is Ceres, and then you also have Vesta, you have Psyche, Astrea, Juno, Metis, a whole bunch of asteroids, but only the first 20. There are hundreds of thousands of large asteroids. And so we see as 3i Atlas is moving through the solar system, let me hit play, it's cutting right through the main body of the asteroid belt, because the orbital eccentricity of the asteroid belt is about 0.4 or less, and then also the inclination is about 30 degrees or less. So that's quite high. I mean, for example, we see here asteroid number 2, Pallas, right there. Check out its orbital inclination. It's tremendously high. It has a very high value, whereas 3i Atlas here is effectively coming in 5-degree angle. So it's cutting right through this asteroid belt, because a lot of them are significantly above or below the ecliptic plane. And we see 3i Atlas will pass below the ecliptic plane in about November, December. So I think it's actually more so later in November. But right now it's above it, but we see it intersecting right through there. You'll see some close calls, but you won't see any direct impacts or contacts with this transit with these 20 objects. But keep in mind that there are hundreds of thousands of large objects. There's millions of smaller ones, and ultimately there's billions of objects in the asteroid belt, and they have their own unique interactions within the solar system, not only gravitationally, but also electromagnetically, just like 3I Atlas. Let's check it out. The asteroid belt is very interesting because, again, it has this huge population of objects. Whereas you go to Earth's orbit, you have the Earth, you have the Moon. There are some near-Earth asteroids, but there's not that many. There are millions, billions of objects in the main asteroid belt. We see near-Earth asteroids there in blue. Here's the main asteroid belt there in this orange color, and then there's other regions that go even beyond that. You have Trojans, you have Centaurs. There's a whole bunch of very interesting things as it relates to the asteroid belt, and it is one of our primary windows into how the solar system formed. One of the new things that we've learned is that a lot of the asteroid belt is actually made up with these trans-Newtonian objects. And so the NICE model, which is a gravitational model that explains the outward migration of the gas giants, also hypothesizes that that would destabilize objects in the Kuiper belt that were forming and have them migrate into stable orbits within the main asteroid belt. This is interesting because trans-Newtonian objects are quite a bit different than main belt asteroids. Main belt asteroids have a density of about 2.6, 2.7 grams per centimeter cubed, whereas a trans-Newtonian object has a density of 1 gram per centimeter cubed. That's less than the bulk density of the sun, which is about 1.4 grams per centimeter cubed. So they're very rich in volatiles and also water, and they're structurally weak. And because of this off-gassing, they can, as they get close to the sun, they off-gas pretty readily. That's causing there to be this coma that can surround them, also water, ice, and dust particles. And so, as we've been talking about with 3I Atlas, in this dusty complex gas plasma surrounding it that has a lot of electromagnetic dynamics to it, the same is true of a lot of these objects in the asteroid belt, though on different scales. So the smaller an object is, the larger the dust grains can be surrounding it and kind of levitating in place, whereas a larger object will have smaller dust grains. So there is also a size distribution here. And one of the just very basic things to think about as we explore into plasma physics here is just the electrostatic field. So you have an object and it has a certain gravity based off of its mass. And that's a force pulling things down. But you also form these electric fields that have an electrostatic potential to them, which, like rubbing a balloon on your head and the hair will stand up, will cause things to kind of hold in place. And the smaller a dust grain is, the stronger of an effect that electrostatic force has. So it depends on the size of an object and the electrostatic field, but what happens is there is a natural boundary where the two are in equilibrium, and this is where you'll get dust grains that resonate with that equilibrium to hang out. And so you will have these layers of dust grains going out from an object that has an electrostatic field around it. And well, these asteroids have these electrostatic fields because you have solar radiation and the solar wind causing ionization and also off-gassing of asteroids and these trans-Newtonian asteroids, which are in there, and more. For example, Eros, which is an asteroid, has a levitating dust layer with a grain size about 2 millimeters. Eros is a smaller asteroid, not the smallest, but compared to the moon, for example, where its levitating dust layer is calculated to be around 0.07 millimeters, because the moon is much larger, and so gravity is much stronger on the moon compared to the asteroid Eros. So you can have these larger dust grains in that equilibrium spot versus the moon. And we know these dust physics because of a lot of our lunar missions, where they noticed these dust clouds that formed on the moon. In fact, lunar dust is one of the big problems that we face in terms of getting back to the moon, because it's very abrasive and corrosive and causes a bunch of problems. And if you want to set up a permanent lunar base, you have to figure out lunar dust. So we have also, for example, the dwarf planet Ceres doing this off-gassing of volatiles, and there's this non-differentiated layer within Ceres, whereas other asteroids are more differentiated. They have a more layered structure to them, like Vesta. There's even evidence with the asteroid Vesta that used to have a core dynamo early on in its history, which means it generated a magnetic field. That's because there is a remnant magnetization on the surface of Vesta. And Vesta is smaller, but has like these differentiated layers, whereas the dwarf planet Ceres has some differentiation, but it also is just a little bit more uniform throughout its interior structure. And there's like this slushy layer that exists, this low viscosity layer within the interior structure of Ceres. So there's a lot of very interesting things. The gravitational effects can cause there to be this off-gassing. You have these electrostatic dust layers that form. And what happens is in space, in general, you have the solar wind in our interplanetary space. You have the solar wind full of plasma going out in all directions. We're all contained within the heliosphere. So we're all immersed in this bubble of plasma. Well, it's not just plasma. There's also a tremendous amount of dust in the interplanetary medium. In fact, the particle densities, a dust particle or a plasma ion particle are about equivalent. And so the moment you introduce dust grains into the equation, the physics gets really complex. And plasma physics is already still not completely understood by a long shot. It's already very complex. That's why they call it complex dusty plasma, because now the dust grains are exerting all their own effects on the plasma and vice versa, and you still have to account for gravity to some degree, and it gets really complex really quickly. So not only does interplanetary space and just the solar wind contain dust, and therefore it's all a complex dusty plasma, so too does the asteroid belt, especially the asteroid belt, because of all these objects, and they occasionally have collisions and pump out these dust grains. We can see that here with the DART mission, where we actually launched an object at an asteroid and impacted it, and it created a very significant dust plume around it. It took some time to dissipate. And so all these objects, or at least a lot of them, are interacting with the interplanetary magnetic field in unique ways. For example, Ceres, it interacts with the solar wind and actually causes the solar wind to pile up in front of it, and then it creates this longer disturbed tail region behind it going out 250 Ceres radii downstream, which is a pretty significant distance when that radius is about 450 kilometers. So you have all these interesting effects. 3I Atlas is flying through the main asteroid belt, right through the body of it, with this coma that is about half the diameter of the sun. It's going to keep getting bigger as it gets closer to the sun. It is now forming a tail, which we know that there's these unique filamentary electric currents that flow through the tails of comets. And what we often see is that comets trigger or are seen to be associated with pretty intense solar activity. We can look at comet Shu-Chin-Shan in October 2024 to see that. We can look at Oumuamua, which did not have a coma or a tail in 2017, but that was perfectly aligned with some really intense solar activity. We also had comet Pan-STARRS in 2013, which perfectly lined up with some intense solar activity that launched towards Earth, and it was all perfectly aligned to do so. So this transit of 3I Atlas through the solar system is going to be very dynamic, and you don't have to think it's aliens for that to be the case. Just the normal physics of our solar system, which we do not understand completely, by the way, allow for a whole range of potential for 3I Atlas interacting with the sun, the other planets, objects in the asteroid belt, and more. And you can't rule out the potential of a collision. This is a huge object. It is possible that something runs into it or it runs into something. We haven't identified all the big objects in the asteroid belt. We're finding more and more literally every single day. There is a non-zero potential that it gets deviated from its course. And we hope that it doesn't get deviated towards the Earth, but technically it's a non-zero potential. So we have to be very, very mindful of these objects. We have to find them as soon as we can. We have to track out their trajectories. We should also be performing the calculations on what may happen with the objects that we know of. There's a reason why we've been putting so much energy and effort into advancing our technology and computers and Moore's law. And if we're not doing these calculations, which we have the ability to do so now with our supercomputers, then what are we doing? Are we just going to go off of blind hope that everything's going to be fine? Like, we really should be doing these calculations as soon as we get them. That's what I would hope. That's what makes sense to me, but I'm just one person. But one other thing to keep in mind too, as it relates to 3I Atlas interacting with the solar system and potentially with Earth through some of these more indirect means, like its dusty complex plasma, is that we find that when you have dust clouds in the solar wind, it can strengthen the interplanetary magnetic field and overall cause it to be enhanced in strength. And we know that within the solar system, there is an inwardly flowing electric current that flows from the outer reaches of the solar system to the sun. And so you have these dust grains which take on a charge, whether it's positive or negative. They typically will take on electrons because electrons are highly mobile and they'll stick to the dust grains. But if there's a lot of photoionization of that dust grain, it can release those electrons and take on a positive charge. This is what makes it a complex dusty plasma, because now you have these different dust grains across a whole spectrum of size with positive and negative charge interacting with plasma in a whole bunch of ways. It gets really crazy. But these could be generated and they're off-gassing from 3I Atlas, hypothetically, and then flowing down this inwardly flowing radial electric current. And therefore, as it sweeps through the inner solar system, cutting within the orbit of Mars, this could create these packets of dust, which then could hit the Earth and trigger enhanced geomagnetic activity, especially if that combines with solar activity that happens to line up with that. So there's a whole bunch of dynamics that are only beginning to piece together, but if things line up in a certain way, this transit of 3I Atlas could be a lot more dynamic than people are saying, and we don't have to go with the aliens explanation, though it's certainly useful, in my opinion, to look at these objects from that perspective, because we are not alone out there and we should be prepared for all possibilities. And as we continue building out our rocket technology and our understanding of space, eventually we're going to become a solar system species and eventually interstellar species. So this in many ways is a wake-up call, not only from the space weather perspective and also just from the maybe 3I Atlas impacting the Earth perspective. Again, that's a super low probability, but we should be doing those calculations with all the objects that we have in our ephemeride data for the asteroid belt and near-Earth asteroids and more. It's also a bit of a wake-up call as it relates to, well, is there maybe some sort of advanced technology or other species out there, intelligence, life, whatever, that is interested in what's happening in our solar system? It's a good question to ask. So more and more evidence is coming out that 3I Atlas is a comet. It is growing a tail, though slowly, and it doesn't look like any comet that we've really seen thus far. It is a unique object having come in from interstellar space. It's only the third ever interstellar object that we have observed. But you have to also keep in mind with all this is that there's a lot of different ways that you can explain things. For example, not saying this is the case, but this object theoretically could have been in the Oort cloud and just accelerated to extremely high velocity. The velocity it's traveling in right now, which is about 60 kilometers per second. All we know is exactly when we found it and the measurements that we've had since. Its orbit before we observed it is interpreted, right? It's interpolated based off of its current orbital trajectory. So while we think that's probably the case, we can't 100% conclusively say, oh yeah, it came in from interstellar space. That's the most likely outcome, makes the most sense. That's what the data suggests, but we can't conclusively say that 100% with confidence. Nor can we 100% with confidence absolutely claim that it is a comet. That's why I've just been calling it an interstellar object, because it's been defined a lot of normal cometary behavior. It's only now beginning to form a tail. It's coma that's surrounding it. This, this kind of bubble of gas and dust and plasma is huge, half the size of the sun. That's much bigger than normal comets. It's a bizarre object. We'll keep tracking it here on the channel, so if you'd like to stay up to date with 3i Atlas, then please subscribe. Again, I've been your host, Stefan Burns. Thank you all so much for watching. We also cover what's happening with the Earth energetically, which means earthquake activity, volcanic activity, changes in certain geophysical energies like the Schumann resonances. We track solar activity, space weather, planetary resonances, planetary geometry. That seems quite significant. 3i Atlas is making a bunch of very precise alignments with the inner solar system during its superior conjunction as viewed from Earth. That's kind of wild. It's having that close flyby of Mars and also Jupiter, which is quite strange. So we track all that, and of course these interstellar and galactic forces. So please subscribe to the channel. We're on the road to 500K. Hope to see you here before we blast past that. We are on the way to interstellar space. We may be flying out there with 3i Atlas. And if you like my work, you can pick up something at earthevolution.com/store. There's a whole bunch of holistic wellness products there, as well as merch and earthing shoes. Thank you all so much. Wishing each and every single one of you well. Please take care of yourselves. I'll see you all in the next video.